So X, well, let me read the question first. It says you have 40 minutes to exercise at the gym, so you total of 40 minutes, and you want to burn a total of 300 calories. How much time should you spend on each machine? So anytime you're like comparing two things, those are where your X and Y are going to be. And in this case, it's talking about the two machines. So I'm going to go ahead and make X the elliptical and Y the bike. And I'm just shortening it by calling it a bike, because it is, right? And each machine burns a certain number of calories per minute. So in this case, the elliptical burns 8 calories, while the bike burns 6. So I'm going to start with that 40 minutes. So you're actually going to be writing both, or working out on both machines, okay, for a total of 40 minutes. So our first equation is going to be X plus Y equals 40. The second one is going to be in reference to the calories. So how would I start this one off? Scout.
You would start off by putting X, then 8.
Right, so 8X. All right, and then?
Then 6Y.
Good. And that, of course, equals 300. Now, we could graph this by hand. There are other ways to solve, but today we're going to solve by graphing. So I'm going to go. So that means my solution is 30, 10. So how many minutes are we spending on the elliptical? 30 minutes. And then how many minutes are we spending on the bike? 10. Good. And then you can also check that. 30 plus 10 is 40. So that works. 30 times 8 is 240. 6 times 10 is 60. So 240 plus 60 is 300. So that works. I just don't have space to write that. So that's why I talk through it. Okay. And I'm actually going to graph this system. Hopefully it doesn't give me too much grief. Oh my goodness, I'm sorry. Let's see, X plus Y equals 40. And then 8X plus 6Y equals 300 are our two equations. And of course, one of them goes off the table, so I'm going to zoom out so I can see where that intersection is. And you can see now that it intersects at this little spot right here, which happens to be 30, 10. Let's try another one. The first thing I'm going to do is designate my X and Y, so I'll do that off to the side here. What is our X going to represent? Possibly. But what does the 6 represent? There you go. So we can make X large. So that means Y would have to be small. And to label these, the smalls are $4, the largest $6. So we're looking at two different things, a total of $144 and a total of 28 candles. Anybody want to take a guess at what one of those equations could be? Go ahead, Emma. Close. X plus Y equals 28, because that's your total candles, right? All right, anybody else want to give the second one a shot? Scout?
6X plus 4Y equals 144.
Very good. Thank you. So now that we have our two equations, we can actually go and graph them. So then our solution is 12, whoopsies, 16. And of course, 12 is the large candle, 16 is the small. Because this is your X, this is your Y, and it comes from here. Questions about this? All right, I have one more. So 4x, let's delete 4x plus 6y equals 144, and then x plus y equals 28. Of course, again, I have to zoom out or in depending on, so if I zoom in, the point of intersection, the closer you get, the harder it is to get it like perfect, but there you go. So 12 and 16. I want you to try on your own really quickly. Want to know if 8-2 is a solution for that system. You don't need to type it in chat or say anything out loud. I will send out a poll in just a moment. I only have about half of you that have responded. Mm-hmm. Do you go through Zoom through a web browser, or do you have it like downloaded on as like an app?
It's on the web browser.
All right, good. It looks like about 80% of you has responded, so this is good. I like it. And yes, I do agree that this is a no, because the first one works. The second one does not. You should have ended up with -4 equals 4. Well, that can't be true. So in this case, this would be a no. Remember, you can also use this method. Let's say you have multiple points. You can also do substitution to find the ones that work. And a lot of times it's the second one that you should try, if y'all are noticing.